remember when we looked at trig graphs and everyone was like, I don't know what the point of this is. And I'm like, I know, I'm so sorry. I don't get to teach you that until next year. Now we get to actually combine the stuff we did last year. We are going to combine with the stuff that we're doing now. So do we remember our trig graphs? What is this? The sine wave, you should know that because it's written over here. So the sine wave, remember, goes from 0 to what? 360, because it does a full circle, right? Think of a circle is 360. Yeah. So a circle is 360 degrees. Remember, this is kind of, I put up an animation over here. If this helps you, then great. If it doesn't, then I've replied to your email.
No, the dance for.
Oh, yeah, of course. Okay, so if this helps you, then great. So a unit, if it doesn't help you, that's okay. But a unit circle, if you sort of move a triangle through the unit circle, you can see that it goes to 2 pi, right? This is 6 point something or other. That was the end of 2 pi. So if you spin a circle around a curve to 360 degrees, you can see that's why we have the curvy graph, right? It's talking about the relationship between a triangle inside a circle, right? So again, if that doesn't help you, that's okay. And if you look at that and go, that didn't make any sense to me, don't worry about it. We will keep talking about it. But that's just a bit of a visual representation. So this is what's going on here. Between 0 and 360, the pattern starts again. Exactly, because this is a unit circle, right? So it goes up to 1, down to -1, because this is our circle, right? So it also, we can go backwards to -360. And again, that's one pattern. Every 360 degrees, it repeats the pattern. So we can go up to 720 and have 2 cycles, right? 1, 2, and then obviously it keeps going forever. So when, I'm going to start drawing on this. So when we looked at it last year, let me do what we did last year, and then we will talk about how that relates to the cast diagram that we looked at yesterday. So let's say that we want to look at when, let's do it when it's 0.5. Okay, so if I'm looking when the value is 0.5, right? So when the y coordinate is 0.5, the value of the angle is 0.5, what's this going to be down here? We did it yesterday. 30, right? So sine 30 equals half. So if you remember, so sine 30 equals half. If you remember our 30, 60, 90 triangle, right? So if this is 60 and this is 30, the sine of 30 is half, right? So opposite over hypotenuse. So that's half. And then that was √3 by doing Pythagoras. And if you think about what's going on here, the sine of 30 degrees is 1/2, which is half, right? So this is just what it looks like on the graph. So then the equivalent angle, if we use our diagram and we go across from half, what's this going to be here? Can you tell what this is going to be? 150. Why is it 150? Right, so 30 is from 0, which means 180. We go backwards the same distance. This is going to be a symmetrical graph, okay? So if I go 30 from this direction, I go 30 from this direction, and these two are equal. What happens if I go 30 in this direction, right? I get 210. Oh, I've drawn that badly. Sorry, that's 220, isn't it? That's 220. How do I undo? All right, so this is going up by, okay, so here is going to go down to 0.5 again. This is 210. So then what's going to be 0.5 over this side? 330. How did you get that? Good, 360. So if it's 30 over 180, it's also going to be 30 below 360, which brings us to 330. So you see how every critical point, so if we have the critical points, whenever we talk about these graphs, we always have 0, we have 180, we have 270, sorry, 270, we have 360. This is 270 down here, and this is 90 up here. So these are always the critical points we should be thinking about. 0, 90, 270, so 180, 270, 360. What does that remind you of from yesterday? Yeah? Aren't those the points on the cast diagram? We went from 0 to 90 to 180 to 270. That's what these critical points are representing. So we're making a wave graph out of the unit circle. Let's do this how we did it yesterday, and you'll see it's the same thing. So if I make my cast diagram over here, and I want 30, 30 is over here, right? That was 30. Then if I want 30 in this direction, what's this angle? 330, right? Because it's 30 degrees below 360, which is this one here. I'll do that in a second. So what's this one over here? If that's 30, what's this? This is 150, isn't it? It's from 0. So this is 180. We minus 30. And then what's this one here? This one is 210. So see how these are those 4 points that we found on the graph. That's how they connect. The other thing that I want to say is these two values are positive half, and these two values are negative half. That also matches this. This is a sine wave. In this quadrant, sine is positive. In this quadrant, sine is positive. That's 30 and 150. In this quadrant, sine is negative, and in this quadrant, sine is negative. That's these 2 points there. So these are basically 2 different ways of finding the same information, right? They both work. One is just a different visualizing way of looking at equivalent angles. Does this make sense? So then if you're ever looking at things that are in this section, so let's say that we then are asked to find some, let me go back to blue. If I'm then asked to find equivalent values, right? So I found equivalent values for sine. So often we look at things like between 0 and 360, right? If that was the case, there are only 2, right? There are only 2 positive halves. But what if I changed my domain to 720? Do I get anything extra? How many more answers am I allowed to have? 2 more, because there's only 2 more positive answers, right? There will be 4 more 30s, but 2 of them are negative, so I don't care. I can keep going across here, and I will find 2 more. So what is this one here? What's this one? 390. Why is it 390? Right, it's 360 plus an extra 30. I'm starting my thing all over again. So what's this one? 420. How are you getting that? Right, 450, because this thing here, right, if we think about that, that's 450, and then I'm subtracting another 30. So I now have 4 values from 0 to 720. When sine equals a half, I have 30, I have 150, I have 390, and 420. So again, that would happen here as well. I would just call this 360. So then again, I want this value and this value. So I'm going to add 30 to 360, which gives me 390. And I'm also going to add 150 to 360. Wait, add 150 to 360? Yeah, right. Which gives me, what did I do before? Where am I looking? What did I write? That's not what this is. Why did I write 420? Who said 420? I didn't check that. That's not what it is. You're adding 150 to 360, which is 410, right? That's what just happened to my brain? That's not 420. It's not. It's 510. Yeah, right. So exactly. Okay, so that's what we're doing. All right. So These would be our 4 different values if we have a different domain. So just often they're giving us just between 0 and 360. That's pretty normal, but just make sure if they give you extra values. And again, you can go around this multiple times or follow this for multiple different cycles. Okay. So yesterday we practiced telling whether things were positive and negative. We're going to have to do that again. I'm going to save this before
Is y-axis essentially the sign value, right?
the value, yes.
And so you can
And the x-axis.
For each angle, you can figure out the sign value that's assigned to it.
Yeah. Okay, let's just quickly get rid of that. Oh, geez. Nope, I don't want to annotate anymore. Okay, let's have a look at the tan graph because it's different. All right, so remember the tan graph does this. So how often does the tan graph repeat? Sorry, it repeats infinite times. How often does it repeat? Every 180 degrees, right? If we've got 0, oh, hang on, no. Let me annotate. If I've got 0, what? Okay, annotate. Oh, right, that's what I'm doing. Okay, if I've got 0 here, this is 180, this is 360, right? I'm going up 540, 720. I'm going up 180 degrees every time, which means, where do you think my asymptotes are? Right, half of that. So every 90 degrees, I have an asymptote. Wait, that's not 90. I've drawn that badly. Oh gosh. For your all drawings, I'm not doing that again. Okay, these are going up by 20s. So this is my 90. Okay, so this is my asymptote. And then again, I'm going up every time. So what have I got? 180 plus 90 is 270. So it's there. I'm not going to draw them all. Well, it's not even a straight line. You get my point. Okay, so asymptotes are obviously half of that. So we can also look up equivalent values here. So if I said that, let me get something brighter. So if I said that tan, let's do, so tan of, let's do 60. Okay, so 60 is going to be here too, for 60. Then we, whoops, look up there, sort of about here. And then you want to find your equivalent value. So we go here and we go down. And obviously this is going to be 180 degrees later, right? This is 240. Every 180 degrees, I'm going to get an equivalent value, right? Because it just repeats over and over and over again. So those are, that one's a lot easier to deal with because you're not going positive, negative, the way that the other ones are dipping. These ones are just totally equivalent. When we're doing, so there are also ways that we can talk about identities. I'm going to get away from this now. So let's stop that and let's go